Whenever we do something with industrial AI, it has to have a tangible ROI, right? Businesses, they do not buy anything that's not going to help them either to grow the top line, bottom line in terms of improvements, or both of it. So therefore, we had the discussion about, is AI a hype? And it's absolutely not, because in the industrial context, it always has to prove the value. If it does prove the value, then it's here to stay.
Hello everyone, this is Barbara Humpton, CEO of Siemens USA, and I'm thrilled today to be with Peter Koerte, our CTO and member of the managing board, as he and I are both attending CES. This is the first week of the working new year, and it seems the whole tech world has gathered here in Las Vegas. Peter, thank you so much for joining us.
Well, thank you, Barbara. It's really great being with you here today.
People used to say, why would you go to CES if indeed it's really about consumer technology? Well, it isn't anymore.
Yeah, the amazing thing is that what really makes Siemens unique at CES is that all the companies that are having a keynote here are either our customer or our partner. So if you think about the impact that we have as a company, we impact everybody here that's displaying at this CES. And I think not many companies can say that.
All of the technology that had been built up in the consumer world is now coming to the real world.
That's
where
right.
we do our work. And people are really, they're hungry for the kind of knowledge that we have.
All the big tech partners that we have, like the NVIDIAs, the AWSs, but also the system integrators, Accentures and so on, they're all here. And we all talk about the same thing, and that is, how can we use technology to address the big issues? But then it gets very nuanced and very differentiated. Of course, everybody's talking AI. However, we take that, hopefully, leadership in industrial AI, because our claim of fame is that we say it's not a generic large language model. It's about, making it useful in industry, and that has significant differences. But also what you see is that agentic part of agentic AI now coming. We have to see how that plays out in the industrial world. You have a lot of digital twin talk. This is really interesting, because I thought we're the leader, and B, that others might not be using it as much. Turns out that's not the case. Microsoft's talking about it, NVIDIA is talking about it. And then there's the whole conversation about robots, about humanoid robots, about automation, but really getting that now also mainstream.
What is most exciting is hearing people recognizing that the power of the technology Siemens brings to the table. But it enables more than just doing what we used to do better. It's about being able to do stuff that was impossible before.
Right.
We're going to have the ability to really focus in on the startups, the innovators. So what are you seeing? What's your interaction with them been like?
Startups are obviously not bound by any preconditions from the past, and they can dream and think big. For example, there's this Finnish startup, Spinnova, right, that wants to use wood pulp and waste to create fiber, because fiber and textile is a huge polluter, or a huge issue for sustainability, because it uses so much water. So if you can take some waste, that's a fantastic idea. Or desert control that really tries to convert arid land into fertile land, and all of that stuff. And these startups are very inspiring to me for the cause that they have, very often, by the way, sustainability related, but also for the technology that they need. And very often they turn to Siemens and say, hey, can you help us to build that digital twin? Hey, can you help us to provide the edge and the automation that they need to have? Can you give us a co-pilot that actually really helps in speeding up our employees in all the knowledge that they need?
Now, one of those startups who's with us right now is JetZero.
Right.
Today we had our media day. You had a room full of journalists who were interested in hearing all about Siemens. And we heard through the voice of JetZero. Tell us a little bit about the key messages you want the world to hear from them.
Well, JetZero is amazing because they want to build the next generation aircraft that is sustainable. And that is carbon neutral, meaning zero. And if you think about it, that's exactly what the world needs, because we all tend to hop on planes and fly around. And aviation contributes 3 to 4% of global greenhouse gas emissions.
Sure.
So if we can turn this down to zero, that's a major contributor. But in order to do that, you have to fundamentally rethink air travel. And what JetZero is doing is, number one, they say, if we change the shape of the aircraft today, which is essentially it's a fuselage, and then you have the wings, and turns out this is actually aerodynamically, it's not very efficient. So if you have what is called a blended wing concept, which essentially is all the rows are embedded in one wing, so it's very efficient. And then if you ask, so then why Siemens? And then Tom O'Leary, who was with us on stage, he would say two things. Number one, you guys are not only having the software, this is where you start of designing it in the virtual world, but you also have the hardware. And then he says, and you guys are able to combine the two things, the engineering, the R&D, together with the production. And whatever you do already in the engineering phase and the design phase, you already can look at design for manufacturing, so that by the end that design is frozen, it really can be manufactured very efficiently. And that manufacturing is also going to happen in the United States with Siemens technology, where hopefully we can take a lot of customers to.
Think about not the classic, manufacture of an airplane, but he's rethinking even how the business model will work.
Yeah.
And so it's through the fact that he's got a digital twin, the fact that he's collecting data, he has even the option and the potential to think about different business models.
In aerospace, about a third of the OPEX of an airline is fuel. And so if you are able to reduce that, let's say cut in half, that's a major contributor for that. And then he says, what if I'm not selling the plane, but I'm there's something called bed lease, where actually you give the plane to the airline, but you own it and you run it for them. And that's exactly what he thinks. But in order to do so, then you need to connect to the plane. You need to understand how often it's being used and so on and so forth. And that's, of course, is technology, and we can help him think that. That's one thing. The other one, that's what Tony showed us today, is with generative design. We can help them to much faster iterate on those designs, right? In aerospace, it's all about weight. And so we have great software with NXX. Today, we showed NXX Design Copilot, where you can tell the machine or the CAD system and say, take that part and then reduce it by all the weight that you need to do, and then it comes up with a perfect design. That's exactly what they are.
And so here we are with a great use case from aerospace, and it's fascinating because we work across all of these market sectors, and over again, you can see people applying the common building blocks. And I want to spend a little bit of time with our audience talking through that. Let's start with the digital twin, because isn't that the building block that enables the rest of it?
Absolutely. So the digital twin is, depends on what comes first, but it's the replica of the real thing. And the trick of that is that the digital twin behaves the exact same way as the real thing does or would.
It's not just an animation.
It's not an animation.
It doesn't just look like the end product.
So therefore, two words do matter: physics and comprehensive. So what we say is, it's good to have a mechanical representation. This is usually what you see first, right? It's the design. But then you say, well, this thing has to have the same way in terms of aerodynamics, in terms of acoustics, in terms of electromagnetic, and so on behavior, as it would have in the real world. Why does that matter? It matters because the more accurate you are in the digital representation in the digital world, the less you have to iterate in the real world, because it's behaving exactly the same way. So less iterations, less time needed, less money spent. So now we can really build the best digital twin out there in the world with proven benefits for our customers.
You've got some wow statistics about how widely used our comprehensive digital twin really is. Talk to us about the market segments where there's been huge customer uptake.
So digital twins are used usually in aerospace first, because this is where all the top 12 aerospace and defense companies rely on our Siemens Accelerator, which brings not only the software together, but also the hardware that is required to do so. Then all the automotive manufacturers, right, and all the major EV manufacturers, they use our software. But then there's the battery suppliers, there's the consumer electronics. They all rely on the portfolio that we provide to them. So the world really runs on Siemens Accelerator and the software that we provide.
Jensen Huang is actually giving a keynote here at CES, and we're due to get down there to hear it. We heard Jensen actually refer to this as the operating system of the industrial world.
That's right. And what Jensen can see clearly is that Siemens is very much ingrained in the 25 industries or verticals that we serve today, be it aerospace and automotive, but then there's food and beverage, there's consumer electronics, there's utilities, all of them, right? And very often it's hidden.
And once we understand, hey, there's potential everywhere. Everywhere there's something real, there's the potential to interact digitally and combine the real and the digital and actually get enhanced performance. So the second place I want to take us is to the software-enabled automation.
Yes. So software-enabled or software-defined is really a trend that we see everywhere.
Yeah.
That's why last year, but also this year at CES, we see a lot about software-defined vehicles. And as people would say, right, Tesla is a computer on wheels. And the reason being is that most of the functionality is abstracted into the software. And the reason why that happens is because the innovation cycles in software are so much faster than they are on the hardware. And that's not just unique to automotive. This happens in the consumer electronic industry, but it also happens in our industry. So when you think about our automation equipment, what that is it's a box with a microprocessor in it and what we call a real-time operating system. And the magic is the real-time operating system. And you could put it into an edge device and you can abstract the whole thing. And that's what we call then software-defined automation. And if you go all the way and abstract that. And that's really intriguing because for our customers, that means they can deploy the software wherever they want to. For us, it means we can think about how the way we ship it, it's a different thing. How often we do the updates is a different thing. So a lot of opportunities come with that.
Well, and it's an opportunity even to go into heterogeneous environments. Not all of our customers are JetZeros who are building factories from scratch. We're working with people who have a long install base with all kinds of different automation equipment in it.
Right.
That software-defined automation, the ability to sort of overlay a software control layer is a game changer.
It is a game changer because it's not just only the operating system that you define, but it's also everything around it, the tool chain. So the way you program it is you can do it in a much more modern way, and hence there's the whole ecosystem around it that we're going to build, and that makes it much more conducive also for younger generations in order to take that up.
Yeah, now here we've got the digital twin, we sort of know what we're going to build, or we've modeled the factory where we're going to build it. Now we've got this software-defined automation where, okay, now we get sort of two-way flow of information of what's happening in this very complex environment, producing a lot of data. That's a perfect application for industrial AI.
That's right. So industrial AI, it really is completely undervalued. And here's the two reasons why. Number one, whenever we do something with industrial AI, it has to have a tangible ROI, right? Because our customers, they are B2B, I mean businesses. They do not buy anything that's not going to help them either to grow the top line, bottom line in terms of improvements, or both of it.
Yeah.
So when we talk about use cases, they want to see the benefit, otherwise they will not buy it. So therefore, we had the discussion about, is AI a hype? And it's absolutely not, because in the industrial context, it always has to prove the value. If it does prove the value, then it's here to stay. And the second reason is because of the data. So we know that those large language models are actually running out of data. So we have about 100 billion words out there in the world. And with that, we've trained those large language models. If we were now to take all the books ever written and digitalize them, we would get another 100 billion words. And then you add 200 billion, but still it's not enough. So it's a big issue. And also all this synthetic data generation, turns out, doesn't really help. The great thing is, we don't have that problem in industry. Why? Because we got these 17 billion smart devices that are sending much more data than any human can ever write in their life. And this is growing at 20%. And so there's a huge amount of data coming our way. And the best thing of it is 80% today is not even used for many reasons. Either the machines are not connected, or the data that's coming out of it, it's not translated so that you actually can compare it. There's many more obstacles, but therefore the potential is so much bigger. So one of the biggest issues that we have out there is skilled labor, right? In 2019, the average tenure of a factory worker was 20 years. And apparently, it has dropped now down to 3 years.
So what we're seeing is the retirement of a whole generation of people who'd been in manufacturing. And then this question of, if people are entering now, are they staying?
That's right. Yeah. So it's both, right? So finding the people and then keeping them is really a big issue. So therefore, all these baby boomers that are now also going to start to retire, all the knowledge that's going to walk out through the door is lost. But what if we could take that information and put it into a co-pilot, conserve it there, and then really provide it to any factory worker? That's a game changer. And that's exactly what we're doing with the co-pilot.
I heard you today at Media Day, you were announcing quite a few different new capabilities, everything from expanded industrial co-pilots to the virtual reality viewer.
That's right.
I'm very interested in your thinking about how important is that visual capability to our ability to reach our audience.
So what we announced today was the Team Center Digital Reality Viewer. That's the right word or name. And what it does is, our digital twins are pretty much engineered digital twins, right? They're very accurate, but they are not the most best looking because they are not what we would say photorealistic. And sometimes you do want to understand how is the car, how is the plane going to look like. And so it turns out NVIDIA, as you know, as a gaming industry, a company where they started, they're incredibly good at doing that, right? And so we built now an interface where we can send any geometry over to NVIDIA, do the photorealistic rendering, and then send it back. And that's good for customers that want to, explore the final touch of the product. But still, you need to have the digital twin, and that, of course, this is coming from Siemens. But then, once you have that photorealistic product, you want to really see it like it was real, right? So that's where the Sony headset helps. So the Sony headset, which is a mixed reality headset, it enables you to look at it in 3D in a super high fidelity view, and together with other engineers to manipulate it and to collaborate and change the design and whatever that is.
I want to talk about one other topic about how the technology we're discussing can really move the needle on an important aspect. We talked about JetZero and their goal to reduce emissions in aviation. And as I look across all of these 25 market sectors that you're helping us focus on, there are these kinds of problems everywhere we go. And so I'm a firm believer that the digitalization and sustainability actually go together. But there's even one more thought, which is that it could actually not be at a cost, right? You hear people say this all the time, that, hey, there's the sustainability price trade-off.
Sure.
But what if there isn't?
Yeah.
What if you could actually engineer something that is cheaper, more efficient, and helps achieve our goals? I mean, I'm sure you're seeing examples of that today, even in with the customers that you're talking to.
Everywhere. As a matter of fact, I mean, this is where everybody started. If we take the two together, so the sustainability and digitalization, sustainability is an outcome, right? Which means less CO2, less water, less resources. Digitalization is a means to an outcome, meaning, you use data to make things more efficient. And very often it's the same thing. It's the two sides of the same coin. As a matter of fact, for me, that's what that is. And this is what we see in so many use cases over and again. So my example for the buildings, where we said, by connecting our AI to the cooling system, reducing energy efficiency or improving energy efficiency by 30%, that's pure bottom line, right? Less energy cost, but it's pure CO2 savings. So very often, in particular, everything that's energy efficiency related, that's exactly what it is. We know that 80% of the life cycle cost that are then also linked to energy are determined in the design phase. And with our design tools, we're able to make these products or parts or components much, much more sustainable through digital means.
Which brings me to the question I love to ask my guests on the Optimistic Outlook podcast. When you think about the goals that you as CTO of Siemens are leading us into a future. I want to hear your view of, tell us about that future that you're going to be helping our customers create.
That future is going to be a future where obviously we live in a much better way together with the environment that we do, which is very resource efficient, which is very energy efficient, which is, of course, in short, sustainable. Where that future is going to be democratized in a way where technology and opportunities are available for everyone, no matter if it's a large company, if it's a small company, no matter where you sit. It's a future where their knowledge is moving seamlessly across and between people in particular.
It's an exciting future that you're driving us toward, and I cannot be more proud to be a colleague of yours.
And so am I. Thank you so much.
But what I'm hoping is that all the listeners now will go to our show notes, where you'll have links to the things that we're talking about here. And if you have ideas, if you have questions, if you have thoughts you'd like to share with us, please send them along with suggestions to my LinkedIn account. Appreciate it. See you soon.
Please follow us on social media and on your favorite podcasting platform. Thank you for tuning in.